Hello, everyone. So we are talking about whipping. When the whipping happens, there's a plate. We have this plate, sieve plate. There's a downcomer, the weir and downcomer. So there's a liquid pool on this. And the vapors are bubbling out. Correct? So we find out U minimum, which is required, which is based on this liquid height, basically, a velocity, which is responsible for whipping. If this is the velocity of vapor, then you will have whipping. Based on this height, the additional height on the weir, and this is corresponding to basically a liquid flow rate. So this is a minimum velocity you find out based on liquid flow rate and liquid dimensions. And next you find out velocity minimum based on vapor flow rate and area of hole. Yes. So if this velocity of vapor found on a flow rate of vapor is more than a minimum velocity of vapor found out based on the liquid parameters, if this is higher than U minimum, I'll say U minimum liquid, U minimum vapor, then you say there is no V. Clear? Now for this, what is required? You require to find out weir height. You require to find out area of hole. That will see. You require the length of weir. You look at this, weir will be like this, and it will have the length. So you have to find out this height as well as length of weir. So weir height. So for column above atmospheric pressure, near atmospheric, this height should be 40 mm to 90 mm. Typical range is 40 to 50 mm. So we have taken 50 mm as recommended height. For vacuum operation, it goes down to 6 to 12 mm. We also required to find out hole size. The hole size, it can vary from 2.5 to 12 mm, but preferable is 5 mm. So we have taken DH equal to 5 mm. Diameter of hole. And this is the hole pitch. We may have a triangular pitch or square pitch, so it's 2.5 to 4 of diameter. Correct? So let's start. How do you find out this U minimum based on liquid parameter? Now, this is a formula to find out minimum vapor velocity is a function of K2, diameter of hole, density of vapor. Now, this K2 is found out from a graph which is a function of HW and HOW. Now, how do you find out HOW? HW is the height of weir, which we are assumed to 50 mm, correct? Now, HOW is additional height. When the flow is there, it will flow little above and then come down like this. So this is additional height, HOW. This height of weir is HW. So this depend on liquid flow rate, and the small LW is weir length and density of liquid. Now, how do you find out weir length? Weir length depend on AD by AC. So AD is a downcomer area and AC is a column area or area of plate. So we have taken this can be 12 to 20%. Recommended is 12 to 15. So we have taken 12% as a downcomer area compared to the whole plate. So we'll go like 10 and 15, 12. We come down. So LW by DC is around 0.76. So you know column diameter, whatever column diameter you have, the final column diameter, 0.76 of that would be a length of pier. So you find out length of pier. This is a liquid flow rate. Now we are talking about a weeping occurs at lower flow rate. So you take 0.7 times the flow rate of liquid in kg per second. Because weeping offers everything on a smaller side. So 0.7 times of LW, this would be a flow rate of liquid. Density will remain same. LW we found out from this, which will give me HOW. Now HW was 50 mm. Let's say HW comes to be around 22 mm. This formula, where LW is kg per second, small LW is a wear length in meter, and you will get HOW in mm of liquid. So HOW is 22. So HW plus HOW would be around 72 mm. Now from this graph, HW plus HOW around 72 mm. Let's go up. Go left. You will get K2. There is K2 here. Let's say K2 equal to 30.5. Substitute this K2 in this formula and get velocity. Yes. So this is a velocity, minimum velocity of vapor based on a liquid conditions. Now, this is what UH, which is vapor velocity based on liquid condition. Now find out UH, I'll say UHL, based on vapor condition, which is equal to flow rate of vapor into 0.7, because again looking at minimum flow rate, divided by area of hole. So I just revise, we have area of plate, area of downcomer is 0.12 of area of plate, 12%. But we have seen in the plate, actually this area is also not utilized and this area is also not utilized. So basically, actual active area would be area of plate minus twice of area of downcomer. And area of hole is around 10% of active area. So this would be area of hole. So this will substitute here. We know flow rate of vapor in meter cube per second. You'll get area of vapor at minimum condition. So now this U and V, if it is more than U and L based on liquid flow rate, then so this is a case if this vapor flow rate is higher than a flow rate of vapor which causes peeping. U and L. Hence there is no weeping. If weeping is occurring, what will do? You will reduce area of hole so that this vapor velocity will go down, go up, than this, and there is no VP. So you can play with area of hole from 2.5 to 12 mm. Recommended was 0.5 mm. So we have taken 0.5 mm as 5 mm. So 5 mm we have taken as recommended diameter of hole. Okay. Thank you so much. This will help us to find out VP.